In this segment of the tutorial, we're going to do sulfonation of benzene. So this is organic chemistry. We've done the nitration of benzene. Now we are concentrating on sulfonation. So we're trying to see how we can make an electrophile, which is used in the sulfonation of benzene, and also the reagents which are used, including the mechanism involved in the sulfonation of benzene. So let's get into it. Okay, so we're doing sulfonation of benzene. So about sulfonation of benzene, we are just trying to look at the addition of a sulfate to benzene. So basically that is what we are concentrating on. So before we can even look at the same process and also the mechanism of sulfonation of benzene, let's first try to understand something here. So we are saying that about sulfonation of benzene, it is just the aromatic substitution, or we can say it is an electrophilic aromatic substitution reaction where this group SO₃H is added to the benzene ring. Okay, so that is basically what sulfonation is. So what we are saying is that it is just an electrophilic aromatic, because we are dealing with benzene substitution reaction where the group, which is SO₃H, is added, where this group is added to the benzene ring. So basically this is what we are doing. So let's look at the chemical equation. So the chemical equation, we know that benzene is C6H6. Okay, so C6H6. So we're trying to add sulfuric acid. Then what we are going to get is C6 H5 SO₃H plus H2. So don't worry about this. We are going to look at where all this is coming from, and should be reacting in concentrated sulfuric acid. Okay, so this product which is formed is what we call the benzene sulfonic acid, benzene, sulfonic, benzene sulfonic acid. Okay, so let's look at the reagents which are used in this mechanism. So the reagents, so basically when you're dealing with this kind of reaction, which is sulfonation, we use two concentrated sulfuric acid. Okay, so we use concentrated sulfuric acid. So we'll be reacting one sulfuric acid with the other plus another sulfuric acid. So we use basically the same sulfuric acid, we react it with another sulfuric acid. Okay, then the temperature at which this reaction occurs, it is at 40 degrees Celsius. So it can occur at approximately about 40 degrees Celsius to around 180 degrees Celsius. So this is the temperature, but this also depends on the reversibility of the reaction. So you can try to be making sure that the reaction is occurring at a better temperature depending on the reversibility. Sometimes if the reaction is favoring more the product side, if that is being made when you increase the temperature, then you do so. If it is favoring the reactant side, meanwhile you want to form this benzene sulfonic acid, you favor more, or maybe you try to moderate and reduce the temperature so that the forward reaction can be favored. Okay, so that is one thing we also need to understand. And the other thing I want us to take note is that this reaction can occur when you have a better fuming reagent, and the beta fuming reagent is the same one which we are calling sulfuric acid. So sulfuric acid is a beta fuming reagent. Sometimes we can use a reagent which is known as oleum. So this also can be used, and we know that oleum is just when you react sulfuric acid plus this sulfide. Okay, so we can use this in order to do the reaction. Okay, so the first thing I want us to understand here is how we form the electrophile, which is just in the sulfonation of benzene. So formation of the electrophile. So as I said earlier, we use sulfuric acid, but you know that sulfuric acid is written like this. It's written like this, right? It's sulfuric acid. But see how I'm going to write it. I can also write this sulfuric acid in this manner. I can write it like this. Oh, sorry for that. So I can write it like this. Okay, this is still sulfuric acid, and I'm reacting it with another sulfuric acid. So I'm going to react it again with another sulfuric acid like this. Okay, now see what is going to happen here. So this is now the mechanism we are starting. So formation of the electrophile will be the first step. So as we can see in this reaction, we have this is sulfuric acid, and we also have this, which is sulfuric acid. Or I can write it this way. I can write this as okay. Let me write this as or just the way it is. Okay, in the way it is, it's fine. Okay, just like this, it is okay. So what I'm going to do here is that I'm going to react this to sulfuric acid. So this oxygen here has some lone pairs of electrons. So these lone pairs of electrons can grab one hydrogen there. Okay, so it can grab one hydrogen there. So this bond now will break. Then the oxygen, since it's more electrophilic, will take the oxygen. So what you're going to form, it is this kind. So on this group, more like you just attach a hydrogen to where there is oxygen. So you attach a hydrogen there, then you say, okay, let me just write this oxygen properly. OSO₃H like that, then plus, of course, when this gains an electron, when this oxygen gains an electron, it will become negative. So it will be negative or SO₃H. Take note of this because we'll use it as a base. So we'll use this as our base. And at this point now, this water, you can see that this is actually water, and because oxygen is bonded to three things, it should have a plus there, it should have a positive charge. Okay, so it should have a positive charge. Then this water can leave, so this water will leave. So when this water leaves, this electron which is here, let me use a different ink. Okay, so this water is going to leave. Then the electrons which are here will neutralize the positive charge on the water. So what you're going to have is basically this. So the product, you are going to form the SO₃H. So this oxygen, because it has gotten the electrons, it will leave this sulfur with a positive charge, so it will be plus there. Then we're going to have, of course, this our base, which is negative O SO₃H, then plus also the water which left. So these are our product. So now take note that this is what we are interested in. So this is basically our electrophile. Then we'll just use this as our base. So take note of that. So that will be our base. Now let's look at now the sulfonation. How is sulfonation going to take place? So sulfonation now. So we have our benzene ring here. So we are adding this group, which is here. So that's group SO₃H with a plus. That is what we are adding. So we are adding plus SO₃H to this benzene ring. So this bond here will attack this electrophile. Then what you're going to form here is this benzene ring, but take note there that this bond here is going to break. So you're going to have the electrophile attached here. The electrophile will be attached at this point. Then we have a carbocation at that point. So this is what we have, but mind you, we can do some resonance here. So you can perform resonance. So by just doing this, okay. So you can perform resonance. So with resonance, you use this same. So this is for resonance. So we can have this same benzene ring. So with resonance, we are just trying to write it in a more stable way. So the same thing, we have our electrophile attached there, but we can shift this double bond to come at that point, then that double bond to come at that point, neutralizing the positive charge which is there. Or we can do it the other way around. We can say this double bond comes at this point, then this double bond comes at that point, then the carbocation will shift at that point. So meaning that we'll have our carbocation there, then the double bond will shift at this point and at that point. We can do another resonance structure. Another resonance structure would be, okay, let me just write it here. This same benzene ring is attached to SO₃H. We can perform another resonance structure whereby so the other resonance structure would be this double bond can shift at this point, then this double bond can shift at that point. So have a double bond there and also there. Then the carbocation will shift at that point. So we can perform a number of resonance structures. So we will just do this. So this is what we basically, okay, so we can shift another, we can shift also this double bond to come there, then this double bond can come there. So the carbocation, meaning that it will be at this point. So the carbocation, you can have it here. You can have the carbocation here. Then we have our SO₃H. Then the double bond has shifted to this point and to that point. Okay. So now what we can do, we can also show that there is resonance structure which is just continuously going on until we make a stable compound. So to show that, we can just show it like this. So we can draw a ring inside the benzene ring like that. Then we show that there is resonance going on. Okay, so from what we have here, we can now deprotonate one hydrogen so that we have our benzene sulfonic acid. So what we can do now, so from this ring which we had, so from what we have, which is SO₃, SO₃H, then with a positive charge, which was the positive charge. Okay, so the positive charge was here. So the positive charge is there. Then let's check the double bonds. Okay, so the double bonds are here and there. So now what we can do, there's a hydrogen which is here. Here there is one hydrogen because this carbon is bonded to two things, meaning that actually there are three hydrogen, but we just need one. Deprotonate it so that we can form the double bond. So now we can use the base which we just formed earlier. So this is the base we are going to use. Okay, so we can now use the base which is negative SO₃H. Alright, so let's now use that base. Okay. Okay. So let me just write this. Okay. That is much better. So now we can, and we had a positive charge here. So we can deprotonate this hydrogen by just introducing a base. So the base we can use, it's the same one, which was or negative SO₃H. So this base, because it has lone pairs of electrons on oxygen, it can grab that hydrogen there. So after it grabs the hydrogen, this bond will break, forming the double bond there. Okay, so what we are going to form now is this benzene ring with the double bond. So we're going to have the double bond there, there, and there. Okay, let me just. Okay, so the double bond there, the double bond has formed now there, then with our SO₃H. Remember, in this reaction we also formed water. So water will be the other product which was formed. So this is now our benzene sulfonic acid. So this is our product which we have now formed. Okay, so that is basically our product we are interested in. So this is how you perform the reaction, which is sulfonation of benzene. Alright, so don't forget to like, share, and also subscribe. Then for more tutorial videos, study materials, past papers, quizzes, or if you want everything organized for natural sciences, second year medicine, and second year nursing, and these other health programs, you can subscribe to Meticulous Study Hub app. Also have the website where you have A-level natural sciences, organic chemistry, biochemistry, study materials and videos, physiology, study materials and videos, anatomy, immunology, microbiology, psychology, and also for Cambridge section, including for junior and senior secondary. So you can just contact this number, or you can inbox on WhatsApp or a direct call. Then if you want to contact us via email, you can use the email shown there. Thank you for watching, and see you in the next tutorial.